we're going to finish up our unit on human impacts. And yesterday we started by talking about, well, how has the human population grown? What are some reasons for that growth? Well, we mentioned the Industrial Revolution, the Agricultural Revolution, and how technology and medicine today has allowed us to survive and pass on our genes, continue by reproduction, and how a little bit on how that increase in our population has affected the environment. We mentioned some things such as overcrowding and pollution and decreases in our natural resources. But today when we talk and finish up our unit on human impact, we're going to really pay attention to the pollution aspect of that and how have we, because of our population increase, have caused these different types of pollutants to affect our environment. So one of our first concerns is actually going to be global warming. And global warming just means the unnatural increase in temperature on the earth, so a natural warming of the earth. Some causes of global warming would be those excessive greenhouse gases. So carbon dioxide, which is spelled CO2, and methane, CH4. Those two gases in the atmosphere actually trap in the heat, and this actually leads to an abnormal increase in the Earth's surface temperature. What do we mean by abnormal? Well, we don't necessarily mean that the temperature is going to rise 10, 15, 20 degrees higher than what it normally is. But on average, there is a slight increase in temperature. That carbon dioxide is generally going to come, the major source of that is going to come from the burning of fossil fuels. So if you think about factories and cars, CH4 is going to come mainly from landfills, the decomposition of that waste, and actually from cows excreting as well. In the picture, what you see is the atmosphere here, and CO2 and CH4 acting as a bubble to help trap in more of that heat. Usually what happens is the sun's heat, the radiant heat from the sun will actually enter the Earth's atmosphere, warm up the surface of the Earth, and then from there you'll actually have the heat rising off because we usually have a loss of heat to the atmosphere as well. And it should be able to move back through and out of the atmosphere. However, with that increase in CO2 and CH4, CO2 and CH4 actually block that heat from leaving the atmosphere, leaving the Earth's atmosphere, and will actually cause it to reflect the heat back to Earth. And that's what's going to cause that unnatural warming. So on your picture, you'll want to circle or highlight where it says it's reflected or re-radiated back. I'm sorry, where it says the heat is radiated back from the surface. The effect of global warming on the Earth is like the Earth's having a fever. Okay, if you want to think about the movie The Day After Tomorrow and what happened there and the flooding of the Earth, that's a really extreme example of what can occur. But when you increase the temperature from 2 to 4 degrees Celsius, weather patterns actually change worldwide. The amount of rain in some areas, the amount of snow in other areas, okay? The changing in temperature can change different patterns on Earth and cause there to be things such, or allow for the possibility of polar ice caps melting, and for flooding of those coastal cities, and for the contamination of drinking water with salt water. So all of this is really focusing on that melting of the polar ice caps and how that could be the result of those increases in temperature. One of the second major problems that have arisen because of that increase in our population is ozone depletion. Now, ozone, you want to keep in mind, has nothing to do with global warming. The ozone layer and global warming are two different problems and have two different causes. One thing you'll notice in this unit is that we'll have a cause and we'll have an effect. This is the reason for ozone depletion, and then what are the effects of ozone depletion. Causes of ozone depletion are mainly CFCs. CFC stands for chlorofluorocarbons. This chemical was once used in refrigerants, so in your refrigerators, and in aerosol cans, so those spray cans like hairspray and pan and those sorts of things. We later found out that those CFCs actually destroy the ozone molecules in the upper atmosphere, and that led to this hole or thinning in our atmosphere. Ozone is actually known as O3. So just like how O2 is the gas that we breathe in, ozone is O3. Ozone, when it's high up in the atmosphere, is a good thing, because when ozone is high up in the atmosphere, when the sun is releasing its heat or radiating its heat and the different rays that it releases, we actually, with O3, are able to prevent UV radiation. So actually in the second picture, that's where you're seeing this, that the UV radiation could actually be blocked by the ozone layer. But when you have CFCs in the atmosphere, the chlorofluorocarbons will actually interact with this O3 molecule. And when it interacts with the O3 molecule, will actually create holes in the ozone layer that will actually allow for more UV radiation in. So again, CFCs break down ozone. When you break down ozone, you're actually going to allow for these gaps in the atmosphere where more UV radiation can enter. Another thing to consider is UV radiation is not heat. That's why even on a cloudy day, you can still get sunburn. You didn't feel the physical heat on your skin, but the UV radiation is still there. You can still get burned. The effects of ozone depletion is that now you can actually have this harmful UV radiation reaching Earth and causing increased numbers of sunburns, skin cancer, cataracts, which is a disease in your eyes, and actually crop damage as well, because some plants are very sensitive to that UV radiation. Our third major concern here is going to be acid rain. Acid rain is caused by emissions, so the sulfur and nitrous oxides from cars and factories will react with oxygen and water. So again, a lot of this is the more people you have, the more cars you have, the more factories you need to manufacture things. And with those, we have lots of emissions, lots of smog, lots of fumes. And as those fumes rise up, when it rains down, we're going to rain down and carry or break down those molecules, those sulfur and nitrogen oxides. And when we cause that to break back down, well, the rain that's coming down is now known as acid rain. Just because it's acid rain doesn't mean that when it's raining, it's physically going to burn your skin. But over time, acid rain can really have some harmful effects on our environment and on some of our structures as well. Some of those effects would be lowering the pH of our aquatic ecosystem. So think about lakes, rivers, streams. Some of those animals, some of those plant life are very sensitive to changes in pH. Thinking back to proteins and enzymes. Okay. It's also going to make soil a lot less fertile. A lot of plants can't grow in acidic soil. So when you're raining down acid rain, low pH, you're going to change the chemistry of the soil. It can also harm plant life and damage human property. There are some statues, some buildings that over time with acid rain have actually begun to wear away at those statues. One thing to add here with acid rain, let's remind ourselves that an acid has a pH of less than 7. So technically a pH of 1 to 7 or 6.9. Okay, remember 7 is actually neutral. So let's write 6 right here, and then 7 equals neutral. Pure water would be having a pH of 7, which is neutral. Okay. And then one of our last concerns is the water quality. This does go a little back to the acid rain. But water quality, the causes of changes in water quality would be sediments, oil, fertilizers from the land, illegal dumping, acid rain, raw sewage, heated water from power plants. All of these different things, contaminants from the earth, oil from cars, fertilizers from farms, sediments just from maybe from buildings, from manufacturing, from construction, illegal dumping when trash or toxins aren't disposed of properly. Raw sewage, not everywhere has a sewage system, not everywhere has a way to transport the waste from your restrooms. And heat can also be a form of water pollution. But all of these things can decrease the quality of our water, make it more dangerous to drink. And the effects of this would be disease, okay, to humans, and habitat destruction for the organisms that live in those aquatic ecosystems. But finally, our last concern is going to be biodiversity loss and habitat destruction. The loss of biodiversity meaning the differences in life, thinking about our extinct organisms or organisms that are on the endangered species list. Okay, the loss of biodiversity is really, really great and really extreme. It affects lots of different ecosystems, and it prevents us from being a planet of plentiful. Some causes of biodiversity loss, the loss in life, okay, differences in life, and the loss of habitats is going to be deforestation, draining and filling of wetlands, so thinking of Florida Everglades. And also, you can also have bioaccumulation and biomagnification, going back to this loss in biodiversity. Bioaccumulation is when the greatest accumulation of toxins, let's add that in there, occurs in the lower organisms in the food chain. So you want to think about the little fish are affected first. So what do I mean by that? Well, if we have these changes in our water quality, let's say someone's dumping toxins illegally, well then the little fish that live in that water are going to be the first ones to absorb in that toxin. That's bioaccumulation. Whichever lower organism gets those toxins first. Biomagnification is going to be when that toxin is going to be magnified as it moves higher up the food chain. And this image is what represents biomagnification. So the water here is first what's contaminated with the toxin. Your producers or organisms lower in your food chain are going to absorb or accumulate that toxin first. But when you think about it, that organisms higher on the food chain are going to eat more of these lower food chain organisms. So as they're eating more and more and more and more, if you think, okay, your producers are going to get a little bit of toxin, the primary consumers are going to get a little more of that, the small fish in this, or the secondary consumers are going to get even more of that from this trophic level, and the large fish are going to eat the small fish. accumulating the toxin from the water. So by the time the toxin gets to these fish-eating birds like your American bald eagle, well, the magnification of the poison has greatly increased in parts per million, or the percentage of that toxin. One thing that in this picture you also want to circle is DDT. This is a very important toxin or pesticide. It's really infamous for causing that decrease in the population of our American bald eagle. And that's why the bald eagle was in the endangered species list, because of bioaccumulation at the producer level and biomagnification up at the top. So then you have endangerment and extinction. Endangered species lists, they're really low in population, really low in numbers, and are endangered of extinction. But that's it for our notes today. Please take a minute to look over the picture and understand what bioaccumulation means and what biomagnification means, and we will talk about this more.